Hello guys, welcome to today's tutorial where we want to determine the moment of inertia about XX of our section shown on the left hand side. The section is a composite section. It consists of a rectangle which measures 200 by 300 and then it has a circular hole of diameter 150 millimeter. All dimensions are given in millimeter. Now, for we to determine the moment of inertia of this section, this is what we shall do. We will denote section 1 to be the entire rectangle. The entire rectangle will be our section 1. And then our section 2 will be this circular hole of diameter 150 millimeter. From there now, we have to determine the value of y bar, the centroid. But for us to determine the value of centroid, we have to find the area and the distance to centers of each of these areas. So area 1, as we said, the entire rectangular section, the area will be 200 by 300. And then, which is 60,000 square meter. Then y1, everything we are measuring with reference to x-axis, the bottom line, the bottommost line of this figure. So I will measure from this line here to the center of this rectangle, which is basically 300, 200 plus 100 divided by 2, giving us 150 millimeter. Now, area 2 will be the area of the circular hole. We know that area of a circle is pi d squared over 4, where our diameter is 150. So we substitute and we get 17,671.5 millimeter square. Then y2, this y2 is distance from the bottommost line to the center line of the circle. And looking on this diagram, you find the center line of the circle is 200 millimeters from the bottom line, hence y2 will be 200 millimeter. Now for us to compute centroid, we shall take area 1, we multiply by y1, we subtract because we take this circle as a whole. Now because it's a whole, an opening, we subtract. It will be area 1 times y1 minus area 2 times y2 divided by a1 minus a2. So if we substitute, we shall find the value of y, or the centroid of this particular figure, is 129.13 millimeter from the bottommost line. Then from there, we go to moment of inertia, which is given by Ixx. Ixx means with reference to the x-axis. So this moment of inertia of this figure will be the difference between moment of inertia of the whole which is rectangular, minus moment of inertia due to the circular hole. So for the rectangular, we shall call it Ixx1. For circle, we shall call it Ixx2. Then how do you compute Ixx1? This will be equivalent to BD cubed over 12 plus area 1 times H1 squared. This H1 is just a measure of difference from the centroid of the entire figure to the center of the figure being considered. For example, it would be difference between the center line, or where the centroid is, which is 129.13 millimeter, to where our y1 is, which is 150 millimeter from the bottommost line. And remember, if you are computing moment of inertia, you only cube the side that is perpendicular to the axis of reference. For our case here, for the rectangle, it is 300 that is perpendicular to the reference of axis, which is the x-axis. So we shall cube the 300. And then this one, we call it theory of parallel axis. So this will be equivalent to 200, which is B, times 300 cubed, which is D, over 12, plus our area was 60,000 times. Now our value of H1 is 150 minus 129.13 squared. Because this component is squared, it will not be a mistake to take 129.13 minus 150 squared, because either way, if you square a positive answer, you get a positive. If you square a negative answer, you get a positive. So the section 1 will have a moment of inertia equivalent to this value here. From there, we shall go to the moment of inertia of the hole, which is circular hole. We know that is given by pi d power 4 over 64. And now, due to theorem of parallel axis, we shall add area 2 multiplied by h2 squared. So this will give us pi times 150 power 4 over 64 plus area was 17,671.5. Then we multiply by, we had our y2 was 200 to the center line of the hole, 200 minus y percentage was 129.13, all that squared. This will give us about, this is what, 113,606 and 3 centimeter power. For remember, moment of inertia is given in terms of units power 4. Now, from there, I will now determine the modulus of the section. The modulus of the section will be the difference. We are subtracting because the circular part, we assume it is a hole. It is not available, so we subtract. Now we take the moment of inertia of the rectangular section minus moment of inertia of the circular section. This will give us 36, 25, 27, 411 millimeters power 4. I hope you've enjoyed the video. I will request you to subscribe, like, and share my YouTube channel. And if you are taking an exam in structures and you would like to get some help from me, you can contact me through the email I will be attaching. And also, those who are doing higher national diploma in building and civil engineering as private candidates, you can also reach out through the communication channel I'm going to leave in the comment section, so that we can see how well we can help each other to have this journey a success. Thank you. Bye bye.